In this section, we're going to develop the idea of a limit. And we're going to do that by looking at average velocity and instantaneous velocity. We'll start with this question here. An object is launched from the ground with a speed of 96 feet per second. And we have the equation that represents that. That's negative 16t squared plus 96t. And we're going to find the average velocity between 1 second and 3 seconds. So as we calculate average velocity, we're going to really be looking at slope. And we know from algebra, slope can be represented in a linear function y2 minus y1 over the quantity x2 minus x1. So let's go ahead and calculate that here. Let's do the denominator first. Our x values, or t in this case, are 3 and 1. So 3 and 1. And to find our y values, then we would plug 3 into function s. So negative 16 times 3 squared plus 96 times 3. So you can pause the video and check on a calculator if you want to check my calculations, but we get 144. If we plug 1 in, notice we'll end up with 80. If we clean the numerator and denominator, it's 64 over 2, which gives us 32 feet per second. 32 feet per second. And so that's our average velocity from 1 second to 3 seconds. Well, let's do that again. This time, let's look at from 1 second to 2 seconds. So finding our average velocity at 2 seconds and 1 second. If we plug in 2, we get 128. Notice we've already plugged in 1. That's still 80. And if we clean this up, and you might need to pause the video to check my calculations, we get 48 feet per second. Well, the idea of a limit is to see what value we would get in the future at some other place. It would help us estimate the instantaneous velocity. So we have different intervals here, and if we wanted to make the intervals smaller, we can find the velocity at a certain point. Well, we've already found that the velocity from 1 second to 3 seconds is 32 feet per second. And from 1 second to 2 seconds, it increased to 48 feet per second. And if we were to calculate the same thing for 1 to 1.5, it would continue to rise, 56 feet per second. If we made the interval even smaller, it would get us to 62.4 feet per second. And we could keep going and make the interval smaller and smaller. Here we're just going to estimate, and I see that as we're going up, it's not going up quite as much. And so I'm going to estimate, and I'm going to estimate correctly, but you could verify by making the interval smaller to give us 64 feet per second. Oh, there must be better ways to do this, Mr. Yes, right now we're working on the idea of a limit. And then in the next chapter, we will find calculus and algebraic ways to actually calculate the instantaneous velocity at a point. All right, look for any questions you might have on the discussion board.